Let's look at this exercise together. So this exercise is designed to derive the confidence interval on the population mean, mu, when the population variance, sigma square, is known. In this case, we're going to use Z distribution. So a machine is set up such that the average content of juice per bottle equals mu. Okay. A sample of 100 bottles yields an average content of 48 ounces. Calculate 90% and 95% confidence interval for the average content. Assume the population standard deviation sigma equals to 5 ounces. So in this case, we know this is 100 bottles. This is sample size N, and average content 48 ounce is sample mean X bar. And we also know the population standard deviation sigma equals to 5 ounces. So the confidence interval will be X bar plus minus Z alpha over 2 sigma over square root of N. So now we need to get the Z alpha over 2 for 90% or 95% confidence interval. So in this case, we already give Z alpha over 2 for 95%, that is 1.96. Now let's derive Z alpha over 2 for 90% confidence interval and 99% confidence interval. So if the confidence interval is 90%, 1 minus alpha percent confidence interval is 90%, then what is alpha? Alpha is 0.1 in this case, right? 1 minus 0.1 is 0.9. So we got 90%. Then alpha over 2 will equals to 0.05. So in this case, in 99%, we will have alpha equals to 0.01. 1 minus alpha is 0.99. And then 100, 1 minus alpha will be 99%. So alpha over 2 will equals to 0.005, right? Now, let's draw the normal distribution. This is normal. And we have 1 minus alpha in the middle. And we have, this is two-sided confidence interval. So they have alpha over 2 in this side and alpha over 2 in this side. So this will be, if this area, this alpha over 2, this area equals to, so this is minus Z alpha over 2. This is Z alpha over 2. So if alpha over 2 equals to 0.05, so this side will be 5%. This side will be 90%, and this side will be 5%. So now let's find this location, Z alpha over 2. This is symmetric because this is the distribution. So when the area here, okay, is 5% or 0.05, what is Z alpha over 2? Let's go to the table, and we use this table. This is left. Let me use the draw. This is left-tailed table. As you can see, this is a left-tailed table. Everything is to the left side. So in the table, this is the probability. And we need to find let's go back. So we need to find this area is 5%, 0.05. Let's go into the table, find 0.05, 0.05. 0.05, this here. So this is 1.0505, and this is 0.0495. So this is in the middle. So the location will be minus 1.645. So this is minus 1.64. This is minus 1.65. So in the middle, it will be minus 1.645. And let's go back. So this location will be 1.645. In other words, this location, if it's minus 1.645, and this area will be 5%. If we look back to the table, everything in the table, inside the table, will be the area under the curve. And this is a left-tailed area. Okay, we want to find 5%, that is 0.05, so it's in the middle. And this is the location. This is the location. This is a z value over here. This is a z value. And the z value is 1.645. That is in the middle between these two. Okay, now we find the critical value for z alpha over 2. Z alpha over 2, that is 1.645, and the alpha is 10%, and the alpha over 2 is 5%. Okay. Now, let's find out 99%. So alpha over 2 is not 5%. This will be 0.005. So, and this will be, let's find this value. This value in the middle will be 99%. Okay, 99%. Now let's find out 0.005. Right here, right? So now let's use draw. So this is 0.005. It seems to be in the middle of these two. So it should be minus 2.57 in the middle, 2.57, 2.58. So this value will be, exact value will be 2.576. So for 90%, it will be 90% confidence interval. This will be 48 plus minus. So it should be 1.645 and 5 over square root of 100. For 99%, this will be 48 plus minus 2.5765 over square root of 100. Then what is the confidence interval for 95%? Okay, so now 99%, 95% will be 48 plus minus 1.965 over square root of 100. Okay, so what sample size is required to make sure the margin of error is within 0.5 ounce at 95% confidence interval? So first, what is margin of error? Margin of error is z alpha over 2 sigma over square root of n. So in 95% confidence interval, so we want this margin of error is within, so that it to be 0.5 ounce and at 95% confidence interval. So 95%, this will be 1.96. We know sigma is actually 5 ounce. And we want to find out the sample size. This will be z alpha over 2 times sigma over MOE square. So n will equals to 1.96 times 5 over 0.5. And this is sample size. We need to make sure MOE is within 0.5 ounce. So in this case, because MOE equals to this one, if n increases, so sigma over square root of n will decrease. So MOE will also decrease. And now what we need to do is to get this sample size. Let's use Excel to find out the sample size. So 5 divided by equals to 1.96 times 5 divided by uh, 0.5. This will equals to 19.6. And then let's do the square equals to this value power 2. This will be 384.16. So this n will equals to 384.16. So n should be greater than 384. Okay, so because we need integers, so n will at least be 385. So this finishes the first exercise. Hopefully this exercise give you some ideas on how to find the critical values through this table, and also how to get the 95% and confidence interval on the population mean when population variance is known.